All right, welcome back to our next installment on higher polynomial functions. This is sections entitled Graphing Polynomial Functions, Part 1. There'll be a second part kind of dealing with word problems a little bit more. Let's take a look at this polynomial here. Now, of course, we know that f of x is just another way of saying y. It also serves the purpose of saying, well, whatever x the input is, f of x would be the output. But we're going to go ahead and we could graph this by making a table. And we could pick some numbers out of the air. But we really don't know where this thing is on the graph. It might be way over to the right, or it might be way over to the left, or it might be in the middle somewhere. It's hard to tell. So when we pick values for x, and let's say we just pick some values for x to plug into this, we might find that these are going to produce values that are, possibly in the middle of our graph, easy to find those numbers, but maybe they're way over to the side. So we could graph it, and we'd also have an awful lot of arithmetic to do. If we stuck, let's do the first one just for the fun of it here. If we stuck -2 in here, -2 to the 4th power, we'll see that would be a positive 16. And -2 to the 3rd power would be a -8. And -2 squared is 4 times -4 is a -16. And -2 times -4 is a positive 8. Just turns out that this actually adds up to 0. So that one wasn't too hard to calculate, and we did find one, but all of these would take quite a bit of arithmetic to calculate. Well, the good news is the graphing calculator will do a lot of this for us, and I'm going to let you do that. And we're going to want to graph these in some degree of accuracy. So, we're going to learn how to graph these fairly accurate. So let's go ahead and do that. All right, I've gone ahead, took my graphing calculator, and I've plugged in that function, and we're going to graph this thing. Now, when we go to graph this, we want to try to get it so that we can see the major points in the graph. And what am I talking about, the major points? Well, what I'm looking for when I'm looking for the major points of the graph are these items. I'm looking for, here it is again, I'm looking for things like zeros. Where do they cross the x-axis? That's a major point in the graph. I might be looking for the y-intercept. Where does this thing cross the y-axis? Also, we're going to talk about what we call the relative maximums and the relative minimums. In other words, this graph may turn, and it may turn somewhere. Let's say it goes through here, and it goes down here, and it comes back through here like this. We want to be able to find those places where they are relative to the rest of the area around them, maxes and mins. For example, I want to find this spot right here, so I can see where the graph turns, and maybe this one over here, where I can see where the graph turns, or maybe there's one up here at the top where I can see where the graph will turn up here. So I'm looking for these major points, those zeros, where do they cross the x-axis, the y-intercept, where does it cross the y-axis, and these things called the relative maxes or mins. Like this would be like a relative minimum here. Relative to everything around it, it's the minimum. And here's another relative minimum. This one up here might be a relative maximum, relative to everything else around. So this particular problem, I had 1, 2, 3, 4, 5, 6 points that might be very helpful, so that if I needed to sketch this, and that's what I'm going to ask you to do, is to sketch these with your pencil, is to find these important points on the graph, or jot down the ordered pairs. You're going to jot down all those ordered pairs and come back to the graph and graph these. So our ability to find these particular spots, let's do it again. There's zeros. Any zeros? A y-intercept. There can only be one, actually. relative maxes or mins. There may be one, there may not be any, there may be more than one. So let's go ahead and take a look at our picture and see what we got. All right, we're going to graph this thing now. And I'm going to hit, sometimes the best thing to do is just to start by hitting the zoom standard. So I'm hitting the zoom button here, zoom, and then I'm going to hit standard, which would be number 6 here. You won't see my button push, but I'm hitting zoom standard, number 6. And I'm going to watch the thing graph here. And it comes in from the left, and it goes out. Okay, so it's coming in from the north, going out in the north. Well, that makes sense that it would do that, because being a 4th degree polynomial, I'm expecting that it should enter and exit in the same hemisphere, because it's even. And because this is a 1 out in front, again, we're talking about the leading coefficient here and the leading exponent, I expect this to open up. And that's in fact what happened here. It came in the north, went out in the north, and it opened up. I'm expecting this to happen. Now, as I look at this graph, I can see a few points that look pretty interesting and probably points to make note of. Okay, I can see that there's a 0 right here where it crosses the x-axis. There's another 0 right here. There's a y-intercept right here. Now, it looks like it might be going through 0, 0, and that's possible. But you can't trust your graph. You're going to have to find it for sure. There is another 0 right here. There's actually 3 here. 1, 2, 3. Actually, 4 zeros. 1, 2, 3, 4 zeros. So we should find 4 zeros on this graph. And also, look down here. There's a relative minimum and another relative minimum. So there's 6 points here that are of concern to us. 1, 2, 3, 4 zeros. A y-intercept, that's 5, and 2 relative minimums, so 7. There's 7 points of interest here. Now, we can have you calculate these fairly simply. And we might just start by looking at table, because maybe we can learn a lot looking at table. So I'm going to go second table here. And as I look at table, this was a good choice to make. I can see all of my zeros right here on the table. Look at the y column. Wherever y is 0, 1, 2, 3, 4 of them here, there are the 4 zeros that we saw. Turns out all of these zeros are integers. There's one at -2, -1, 0, and 2. And I would write all of those zeros down, the ordered pairs. -2, 0, -1, 0, 0, 0, 2, 0. And I would jot all of those numbers down. And so I'm going to do it here on the side, and I'll show you this in a second. -2, 0, -1, 0, 0, 0, and 2, 0. Those are my zeros, and we're going to need those. But there's also some other points that are going to be important here. Notice that the y-intercept is right here where the x value is 0. So I already know that is not only is it a 0, it's the y-intercept. And so I'm going to jot that down, that the y-intercept is at 0, 0. So the only thing that we still need to find are the relative mins and maxes. And you can kind of tell a little bit by looking at the table here, but not too much. You'll notice that we can see where things are going from big, positive to negative, and you can also see where numbers get bigger and then they start getting smaller again. But that isn't going to get us very accurate. So let's go back and look at the picture. All right, there are relative mins and maxes. Excuse me, 2 relative mins. There's one right here and one right here. Well, we are going to use the max and min feature in the second calc function. Let's show you where that is. Second calc would be right here, second calc, and you hit second calc, we need to find the minimums. So I'm going to hit second calc, and I want a minimum right here. Okay, number 3 is minimum. And now it's going to go to that process of asking me questions. And so I'm going to take my arrow, my left arrow or right arrow, whatever, and I'm going to put my cursor just to the left of that minimum. So I'm just to the left of it. See, the question is asking left bound. So I want to put my cursor on the left boundary, the left side of that relative minimum. Okay? And I'm going to hit enter. And now it's asking me for the right bound. So I'll take my arrows and I'm going to move it to the right side of that, right about there. Okay? And I'm going to hit enter again. Then it has that silly question, guess. Just you'll ignore that and hit enter one more time. And now, notice at the bottom it says minimum. It has found the minimum for us, and the cursor is blinking right at that point. So I'm going to take my ordered pair, and we could round this to something that's not too difficult. Let's round it to negative 1.6, negative 1.4. And that is a minimum, okay? It's a minimum. And you can see down here at the bottom that the ordered pair, XY pair, and I've rounded to 1 decimal place. If I'm going to graph this with a pencil, the accuracy is not going to be terribly great anyway, so I think 1 decimal point would be probably adequate here. So negative 1.6, negative 1.4. Now, we found one of the minimums, but you can see on our graph there's still another one way down here. So we're going to repeat the process, do it again. So second calc, minimum again. And I'm going to move my cursor with the arrows over here closer to the minimum. Hit enter. That's my left bound. Move it over to the right. Hit enter. And hit enter again. And I got another minimum at the ordered pair. Notice the cursor is blinking right at the bottom there. At 1.3, negative 6.9. So I've got another minimum. All right, there's one last point we didn't talk about, and that is this relative maximum right here. Right at the top, there's a bump right there. So we're going to go find that. We're going to use second calc, and we're going to find the relative maximum. So I'm going down to number 4. Enter. Left bound again, you're going to keep using the same thing. So move your cursor to the left side of that maximum. There it is. Hit enter. Move it to the right side of the maximum. Hit enter again. Ignore guess. Hit enter one more time. And now you'll know notice that the cursor is blinking right at the top. And it says maximum down here, see? So now we have a max at the ordered pair, negative 0.5 or so. I'm going to just round that to 1 decimal place. Negative 0.5, and this is about 0.9. So how many points did we get? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8 points altogether that are going to help us graph this manually. So I've jotted them all down. If you didn't jot them down, that's okay. I've got them here. Now we're going to go ahead and pull away from the graphing calculator and put this on paper. All right? All right, I have jotted down all of the points that we pulled out there before. And as you can see here, these are all my zeros. Here's the y-intercept. I don't have these in any particular order here. The y-intercept is here, the max is down here, and the minimums are up here. And we're going to go ahead and graph this with some degree of accuracy on paper. And this is an important thing to learn how to do. So, all right, we've got a 0 at negative 2, 0. We've got another 0 at negative 1, 0. And we've got another 0 at 0, 0. Also happens to be my y-intercept, so I don't need to graph that again. And we've got another 0 at 2, 0. So there you go. We got 4 points. These are all the zeros. Now we have a relative minimum at negative 1.6, negative 1.4. So negative 1.6, negative 1.4 would be right about here. We've got another minimum at 1.3, negative 6.9. I got to go way down here. 3, 4, 5, 6, 7. Negative 1.3, Negative 6.9 is right about here. Negative 1.3, I'm doing this one here. Negative 6.9. 1, 2, 3, 4, 5, 6. That's right about here. Finally, we have a maximum at negative 0.5. Negative 0.5 and 0.9. Negative 0.5 and 0.9. Actually, it's a negative. I didn't jot that negative down, but that is a negative 9 there. Negative 0.9. So negative 0.5, negative 0.9, is that positive? No, it's a positive 0.9. That is right. So positive 0.9 would be right about here. All right. Now, as you can see, we can kind of, even if I didn't have haven't looked at the graph before, I know what's going to happen here with the graph. It's got to come in from the north and leave in the north, because this is a positive coefficient with a even exponent. So it's going to come in here. It's got to go through that 0, through the relative minimum, come back up, go through the relative maximum, come back through that 0, got to go down here through this relative minimum, and back up through the relative maximum. Now you see, with these points that we have plotted here, our graph is incredibly accurate, and we did it with a pencil. Let's compare that to the picture that we had. Look how closely those pictures resemble one another. Our ability to come up with these important points are a big deal, and our ability to graph those important points. Well, what are they again? They're the zeros, they're the relative mins and maxes, and there's the y-intercept. We want those points, and our ability to find those is critical. Now, there's not that many things to do with the calculator, but there's one thing we didn't talk about here, is how to find the y-intercept if it doesn't happen to be obvious. Well, what you can do to find the y-intercept is use the second calc value feature. I say if I plug second calc value, if I let my x value be 0, that's where the y-intercept is, it will kick out the y value. In this case, it was pretty obvious that it was at 0, 0. But if I needed to use that feature, I could use that to find the y-intercept. So as you look at the calculator, what you needed to use for this calculator was the second calc feature, these items. We had to use value. We had to use value to find the y-intercept. We had to use zeros to find these zeros, and we had to use the max and the min. These 4 items in the second calc menu will help you find all the dots. Let's do another one of these. All right, let's tackle this one here. Before we do, let's make a list of the things we are going to be looking for. We're going to be using finding the y-intercept, and we could do that using the value feature. We're going to need to find the zeros, and we're going to use the 0 feature for that. And we may need to find maxes and mins. We'll know when we see the picture here. Okay, those are the 4 things, and of course we find all of those in the second calc menu. So let's go ahead and put that in the calculator and see what it looks like. Now, before I show the calculator and what we've got for a picture here, let's make a prediction of what this looks like. I'm going to make a sketch here real quick, what I think is going to happen in the end behavior. I'm going to erase this in a second, but I want to see the end behavior. Notice this is a cubic function, a 3rd degree polynomial. In other words, it's an odd function. So I expect it to either come in the north and go out in the south, or vice versa. It'll come in the south and go out in the north. Which way is it? Is it going to be going in this way or going this way? Well, that's determined by the fact that this is a positive leading coefficient. So I'm expecting it to have a positive slope to it, something like this. So I'm going to erase that. I expect it to look something like this. Now, it may have some bends in it. It should start in the south and go out in the north. If you don't know how I came up with this, go back and watch the previous video on section 7.1. It's cubic, so it's going to have to enter and exit in different hemispheres. And it's a positive leading coefficient, meaning it's going to be leaning to the right like a positive slope. So that's what we should expect to find as we go ahead and graph this. Let's take a look at the picture here. Okay, there it is. I've entered it into the calculator now. And let's see what she looks like when we go ahead to graph it. By the way, sometimes the graph isn't going to show you the picture very good. Sometimes you hit zoom standard and you don't see much. So one of the things you can always use, and hopefully we'll come up with one and we'll have to do this in a minute, is hit zoom fit. Let's go down and look for zoom fit. There it is, right there, zoom fit. I can go from top to bottom or bottom. If I go down to number 0, zoom fit, what zoom fit does is it looks for these points exactly the ones we're looking for. It looks for zeros, and it looks for relative maxes and mins, and it looks for the y-intercept. And it will get that in the middle of the graph. Now, it may not show you the x and y axis yet, but it will go looking for those things in the graph. So I'm going to hit zoom fit, and let's see what happens here. All right, now that's kind of a zoomed in version here of this, and it is finding our most important points. It's finding that y-intercept. Looks like it's finding the zeros here, and it's doing what we expected it to do. This picture is not particularly attractive, and I bet you if I just hit zoom standard, it'll look a little better. Let's hit zoom standard. So I'm going to go zoom standard, number 6, and I can see the graph looks a little more attractive. Oh, wow, there's a lot more here than I thought. See, that's what happens sometimes is we got to make sure we've got everything we need on the graph. If I was just to hit zoom fit again, let's see what happens. Maybe it'll zoom out a little bit for me. Zoom fit. Yeah, it's not giving me nearly as big a picture. I would probably want to zoom out to see what's going on here. So let's zoom out and see what's happening. I'm not going to get anything there. Maybe we should zoom in and see what happens. Oh, I was zooming in. Let's zoom out here. Okay, let's zoom out again. Yeah, sometimes we may be zoomed in too far or zoomed out too far. You know, you can't really tell that it dipped down by looking at that graph. I zoomed out again to see if I could figure out what's happening. And it looks even less like it's dipping down. So we may be missing something if we don't actually go ahead and get a good look at the picture. I'm going to hit zoom standard again and get that picture because now I see a little bit better what this is supposed to look like. It actually dips down. On the other picture, it looked like this all kind of blended together in the middle here. All right, as we look at the graph here, we can see that we've got 3 zeros, real zeros. Here they are. And by the way, it is going from left to right here. Entered in the south and left in the north, exited in the north. Kind of got a positive lean to it, and it's got 3 zeros. And we're going to find those, and it's got a relative maximum here and a relative minimum down here. The y-intercept is also got to be found. Let's start with the y-intercept this time. So I'm going to hit second calc value. And let's put where the y-intercept is where x is equal to 0. So down at the bottom I'm going to put a 0 in there and enter. And it tells me that my y-intercept is at 2. So I'm going to write that down. The y-intercept is at 0, 2. Okay? It's not at the maximum, but you might think it is, but it's not. It's not at the maximum. All right, now let's find the zeros. So second calc, zeros. I'm going to hit number 2 here. Let's find the first one. Put your cursor to the left with the arrows. Hit enter. Move it to the right of that crossing. Hit enter again and hit enter one more time. And looks like we have a 0 at negative 0.4, 0. Okay. Let's go find another one. So second calc, 0. We're going to move over and find the one in the middle here. There it is. Enter. Move it down. Enter. Enter again. Left and right crossings. There we go. And we end up with that 1.20. Okay. All right, one more 0. So enter, or excuse me, second calc, 0. It's asking me for left bound here, so I'm going to go down just to the left of this, hit enter. Oops, that's not the right spot, but it's all right. I can go down here and enter here. And I've got another 0. You can see by the ordered pair down there it is 4.20. So we've got 3 zeros. Okay? And we've got the y-intercept. Now we need to go back and find this relative max and min. So second calc, let's find the maximum first this time. Maximum. So I want to take the cursor and move it just to the left of that mountaintop there. Okay, there I'm to the left of the mountaintop. Enter. Now to the right of the mountaintop. Enter. Enter one more time. And I got a max at 0.3 and 2.5. 0.3, 2.5. Okay. Now we need to find the valley here, the minimum. So second calc minimum. Move the cursor just to the left of it. There you go. Enter. Move it to the right. Enter again. And one more time. And I end up with a valley at, it says 2.9 repeating. Well, that's 3. In fact, I think it's exactly 3. Because this calculator was looking for that point and it got it so close, but it didn't get it right on. I'm sure that's at 3, -7. Now we could verify that by looking at the table. I'm going to do that. Let's go to table real quick. On the table at 3 down here, you'll notice it is exactly at -7. So that is a point. Now we have got all of these points. Looks like there's 6 of them on the graph here. Let's point them out again. Okay, zeros, 1, 2, 3 of them. Y max, Y min, and a y-intercept. All of those points are there. Well, let's go ahead and graph this thing. Okay, so I've got all my points listed down here for me, and this is what you do. Just grab your pencil and go ahead and list them all. So there are all my points. This graph is exactly what we were expecting to find. Let's make some accurate drawing here now. Okay, the y-intercept is at 0, 2. I've got a 0 at -0.4. -0.4 is about here, 0. I've got a y-intercept, or 0 at 1.2. That would be about here. And another 0 at 4.2. 3, 4, 1, 2, 3, 4.2 is about there. So there's my y-intercept and my 3 zeros. These were all the zeros here. Okay. And here's a relative max and min. We got a relative minimum at 0.3, 2.5. 0.3, 2.5 would be like right about there. And we've got a relative minimum at 3, -7. 1, 2, 3, 5, 6, 7. 3 7's about here. Now with these 6 dots, we have a pretty accurate idea what this looks like. I know by looking at this cubic function that it's going to start out in the south, it's going to leave in the north, okay? And so I'm not exactly sure how quickly this takes off, but I can kind of tell by the angle here, it takes off pretty quick to the south. There's my max, there's another 0. It's got to come down here and hit that minimum and back out the 0. We missed it a little bit there, okay? Now, that's the graph, and we did it with all of those strategic points here. Let's compare that to our drawing that we had before. And you can see how it's pretty close to what we had before. So this is the same you're going to use on these problems as you do these tonight. You're going to be looking for those major points, those y-intercepts, zeros, maxes, and mins. Remember, to find the y-intercept, you're going to use the value function. Let's do one more, okay? All right, let's take a look at one of the story problems in your book here. I'm pulling this problem from page 356. You might need to go get your book out so you can read along here. I'm going to read it out loud, but you're probably going to want to follow along. So just pause and go get your book and then come back, okay? All right, this is problem number 10 on page 356. The number of cable TV systems after 1985, it says, can be modeled by the function shown here, where t represents the number of years since. So t is years since 1985. You'll remember what to do with that here in a second, okay? Question 10 is asking, graph the equation for the years 1985 through the year 2005. Well, the first thing we're going to have to do is convert 1985 to a different number, because this is years since 1985. So in 1985, years since that would be 0, and the year 2005, well, that's 20 years later. So we are going to graph this from years when t is 0 to 20. That'll be 1985 will be 0, and 2005 will be 20. So we're going to put this in the calculator, and instead of using 1985 and 2005, we're going to use this as 0 to 20 as our x or t values here. Let's put that in the calculator and see what we got. All right, well, after I turn my video off here, I realized I had the wrong number typed in there, or put in there. Hopefully you pulled that number straight from the book rather than what I had up here. I changed this number here so it's actually correct now. And I went ahead and inserted it in my calculator. Plug that in there. Let's blow this up a little bit to make sure we've got it all correct here. Okay. Now, before we graph this, let's make a prediction about what it's supposed to look like. Okay. First of all, it's an even polynomial. That means it's going to enter and exit in the same hemisphere, either north to north, enters in the north, goes to the north, or it enters in the south and goes to the south. Well, looking up here, the coefficient for that leading term is negative. So this is going to enter in the south and leave in the south. In other words, it's opening down. So that's what I should expect to find when I graph this. Now, I'm going to do something that I know is probably not going to work. Hopefully, it won't work. I'm doing it deliberately. If I hit zoom standard, and that's number 6 here, watch what happens. It gives me a line that looks vertical here. Now, we know that a vertical line is not a function. Plus, I was expecting a parabola here. This is an x squared term, right? So I should expect a parabola that opens down, and that's not what I got. Well, what's the problem? Well, the problem is I'm looking way too close to this. you'll notice that our function has a y-intercept of 790. If x is 0, this has to go clear up to 790. So I'm not even close to the vertex at the top there. So instead of hitting zoom standard, I'm going to hit zoom fit and see what happens. Maybe it'll get me closer to what I want to be. Zoom fit, hit enter. And now I see kind of the workings of a parabola. It doesn't look anything like a vertical line. That's because we were so close in it looked like a vertical line. Well, I can't see the top of this graph here. And also, I can't see a scale at all on this side. So I'm going to need to go up some more. So I'm going to hit Window. And I know I have to go up on a Y max. I'm going to have to go much higher than 9900. I'm going to go up to, let's say 20,000. 20,000. I got to go up higher. And let's see if we can see the top of it. Okay. Well, I'm getting pretty close, but it's way off the screen on the right. So I'm going to have to move my screen so I'm going to the right. So I'm going to hit Window again. And I'm going to go X max. Let's go way over to, I don't know, let's go over to 2000 and see if we can see the top of this graph. So here we go, graph. Okay, yeah, I can see the top of the graph now. I went farther than necessary. Let's back off. Let's go up the X max to maybe 500. Maybe my graph will be better. You'll notice that we're spending a lot of time here trying to get the picture to look reasonable. All right, that's better, but I'm still going way too far to the right. So let's change the window X max to something less than that. Let's just go over to 100 this time. And there we go. Now the thing's starting to look reasonable. I think I'm going to bring this in even a little bit farther here. So let's go Window X max. Let's just go to 50. See if that gets us to the end there. Perfect. Okay. Now I need a scale that makes sense for both of these. So I'm going to go to Window and I'm going to change my X scale maybe to go by 5s. So I got to go from like 0 to 50. I'll go by 5s. That'll give me 10 marks. And the Y scale, I've got to go clear up to 20,000. And I don't really need to go clear down to negative 16,000 on the Y minimum. Let's just go down to -5 because I'm just interested in positive Y values here according to the story problem. But let's change our Y scale. Let's go by 2000s. That'll give me 10 marks on that scale. All right. If you need to take a good look at that, pause it and change your window so it looks like this. There we go. Now our graph looks a lot better. It's got scale marks at the bottom every 5 years, and it goes up the side here, and this is talking about the number of cable customers or cable systems, which goes by 2,000 years. So each of these marks on the y-axis is 2,000, and each of the marks on the x-axis is going by 5. So you can tell at the bottom here, remember we're going from year 0, or 1985 is 0, 1985, 1990, 1995, year 2000, what is that? Yeah, actually we're going farther than necessary here, but year 0, 1, 2, 3, 4, 5, 6, and so forth. Okay, so there's your graph, and each of those marks is 5 on the bottom. Now the question asks, graph this equation for the years 1985 to 2005. That's 20 years. So 0, 5, 10, 15, 20. We only needed to go this far. We went a little farther than necessary. Okay. Now question number 11, it says describe the turning points of the graph and its end behavior. Well, its turning point is this vertex up here. and its end behavior is it comes in from the south and it leaves in the south. So you would write those down, that it would enter from the south and it leaves in the south. Those are your end behaviors. And that turning point is at the top. In fact, we can find that if we use the maximum feature here. So I'm going to hit second calc maximum and move my cursor just to the left of that spot. There you go. Move it now to the right bound to be to the right of that spot. And I can see that I've got a turning point at 15.5 and about 11,200. I'm going to write that ordered pair down. That's my vertex, and it happens to be the maximum. So it's telling us that at the 15th year, 15.5 year, in the middle of the 15th year, it reached a maximum number of cable customers at 11,200. Well, what is the 15th year? Well, let's see. That would be about the year 2000, because remember, 1985 was year 0, so 15 years later would be about the year 2000. It's about year 15. So sometime during the year 2000, we hit a maximum. Remember, this is talking about cable customers. And cable TV grew and grew. It grew from its inception, and it got to a point where it maxed out. And instead of having cable TV now, people are not using cable TV. They are using other internet receiving methods. And so it's declined, and now we don't see nearly as many people using cable TV. So question 11 asks, describe the turning points. Well, the vertex is at 15.5, 11,200. Okay, let's take a look at what that looks like on your, I write those numbers down. Okay, so we had a max at year 15. That's 1985 is year 0. So the year 2000 is about year 15. Okay, now question 13, or question 12 is asking, what trends in cable TV subscriptions does the graph suggest? Well, it suggests that it grew till about the year 2000, then declined. Okay, it was a maximum at the year 15.5, which would be about the middle of the year 2000. So you can interpret these graphs if you go ahead and graph them. I think what we found one of the hardest things to do on this problem was to get this graph so that it looked reasonable on the screen. And that's a thing you're going to have to get some skill at and practice at, is learning how to manipulate window. Let me show you that window again. And I had to find that entire graph based upon what I knew about a y squared function, or excuse me, an x squared function. I knew that it was going to be a parabola, so the initial picture I got wasn't any good. But by using window, I could get to see the entire picture, see it in context of the x and y axis by changing some numbers on my window, and then I needed to change the scale so that they made some sense and they weren't just a bunch of tick marks that were too close together or too far apart. This is really one of the hardest things to do on the calculator, is to learn how to manipulate these graphs using window to see exactly what you want to see. This is a very worthwhile thing to practice working with the window. Now, most of the problems you're going to have on tonight's assignment you don't have to do this with. Let's take a look at your assignment tonight. All right, here's your assignment for tonight. I'm going to have you do assignment number 50. There's not that many problems, but you really are going to need a lot of practice, so please make sure you do all of these. Use your graphing calculator and table, if necessary, to find these 4 magical spots: the y-intercept, use value feature, zeros, relative maxes, and mins. That's all in the second calc menu. Okay. And then once you've got all of those ordered pairs to 1/10 or 10th, like 1 decimal place, make a paper and pencil drawing and see if it doesn't look like your calculator graph. It's going to be important that we're able to find all those spots and can make a paper and pencil drawing. Now this is the end of part 1. I'm going to show you another part here, and in part 2 we're going to kind of do some more word problems a little bit. Have a good time.